Welcome. I am Professor J. N. Mandal, Department of Civil Engineering, Indian Institute of Technology, Bombay. Today, I will discuss the testing procedure for modified Proctor test. Earlier, I discussed the standard Proctor test. Now, I will present the modified Proctor test. Now, what are the procedure for the modified Proctor test? Note the dimension of this mold collar and the base plate. Take the empty weight of the mold without the collar and the base plate. Apply a thin layer of grease on the inner side of the mold and affix it to the base plate by means of wing nuts provided. Then place the collar on the mold. Now, take about 4000 grams of air dry soil passing through sieve size 4.75 millimeter in a tray. Note the hygroscopic moisture content of the soil. Now, add approximately 3% to 4% of water to the soil in a tray and mix thoroughly with the towel and cover it with the moist cloth. Next, to determine the Proctor density, place the soil in the mold in 5 layers and give 25 blow to each layer using the modified Proctor hammer. Remove collar, trim the soil with a straight edge, disconnected the mold from the base plate and then weight it. Take 2 samples, one from the top and other from the bottom of the mold for moisture content determination. So, you can determine the moisture content of the soil sample. Extrude the compacted sample from the mold, break it into a original size, add another 3 to 4% of water and repeat the step as to 7 to 10. Continue the operation until a decrease in the weight of soil is observed for at least 2 successive readings. Then draw a plot of moisture content versus the dye density and determine the maximum dye density and the corresponding optimum moisture content. Now, how to calculate this? Calculate this specimen calculation for this modified Proctor test. So, I will show you some specimen. Specimen calculation for modified Proctor test. So, it is a modified Proctor test. Earlier we discussed about the standard Proctor test. Now, regarding the Proctor state detail, that means Proctor cylinder detail. So, it has a diameter is equal to 10 centimeter. It has a height is equal to 12.73 centimeter, and it has a volume, and volume is equal to 1000 cc. Now, this is the Proctor cylinder detail. Similarly, Proctor hammer detail. This is modified Proctor hammer is 4.89 kg, and it has to be dropped 45 centimeter, and number of blow in case of modified Proctor test is equal to 25, and number of layer is equal to 5. So, in case of modified Proctor test, then number of layer is 5, as in standard Proctor test we use number of layer 3. Now, empty weight of Proctor mold is equal to 2325 gram. So, we know that what will be the Proctor cylindrical detail and also Proctor hammer detail. Now, I will show you the table, and this for the Proctor standard test. First of all, that you have to take the weight of the weight soil and the mold, and then weight of the soil, and then you calculate what is weight density, and then you take the different can number. You know what will be the weight soil plus can in gram, dry weight soil plus can in gram, and weight of the empty can, and then you determine what will be the moisture content, then what is the average this moisture content, then you determine dye density, and then the void ratio, and then you can calculate the degree of saturation. I am showing that one calculation here, and like that you can go for the different sample and determine the moisture content and the dye density. Now, let us consider that weight of soil plus mold is equal to 3672 gram. Now, weight of soil will be equal to 3672 minus 2325 gram is equal to 1347 gram, because weight of empty mold is equal to 2325 gram. This is empty weight. So, this. So, you can calculate the weight of the wet soil. Now, you calculate what is weight density. Weight density is equal to weight of wet soil. This weight of wet soil is 1347 and this divided by the volume. Volume is 1000 cc. So, this is volume. So, this will give you 1.347 gram per cc. So, you can calculate the weight density, that is 1.347 gram per cc. You can calculate the water content. Water content is the weight of water, and this divided by weight of solid into 100. That means weight of water, which we can calculate that here this weight of water is about 51.172. Okay, this 51.172 weight of 51.172 weight of water plus can. This minus is, this is dye soil, this is the dye soil and the can, this is 50.480. So, this is 50.480. This divided by that, what should be the weight of solid. That means, weight of solid will be 50.480. This is 50.480 minus this is weight of empty can 36.2. So, this is 50.480 minus this is 36.2. So, this into 100. So, if you calculate this, you can have 0.692, this divided by 14.28 into 100. So, this will give you water content of 4.85%. So, you can determine the water content, that is about 4.85%. Here here it is that water content 4.85. So, you can calculate this 4.85. Now, you have to calculate that what will be the dry density. So, dry density is designated as gamma d, and this is gram per cc. So, this will be equal to gamma of weight, this divided by 1 plus m, where m is equal to moisture content. Moisture content. So, gamma of weight, which we have calculated earlier, that is here gamma of weight density 1.347. So, we can write 1.347, this divided by 1 plus moisture content, and here we are taking that average, this is moisture content, average moisture content is 5. So, 1 plus m, that means average moisture content percentage, it will be the 0.05. So, this will give you the dye density of 1.282 gram per cc. So, you can calculate the dye density of 1.282. So, here where its dye density is 1.282. Now, next is the void ratio. How to calculate the void ratio, and that designated at E. So, E is equal to G into gamma W divided by gamma of D, and this minus 1. So, G that specific gravity which you calculated from the specific gravity test, and this gamma W is equal to 1, this divided by gamma of D. Gamma of D is gamma D is 1.281. So, this is 1.282 and minus 1. So, then void ratio value will be equal to 0.948. So, we calculate the void ratio E is 0.948. So, we calculate dye density, we calculate the void ratio. So, here it is that dye density 1.282, here it is the void ratio 0.948. Now, we will calculate the degree of saturation. Degree of saturation, and degree of saturation is S and in percentage. So, S will be equal to G into M, this divided by E into 100. So, you know that G specific gravity, that is 2.5, M is moisture content 5%, that means 0.05, and that divided by, we calculate the E value, E value is 0.948. So, this is 0.948. So, into 100. So, this will give the value of degree of saturation, is 13.1 percentage. So, degree of saturation you can calculate is 13.1 percentage. So, this degree of saturation is shown here, that 13.1 percentage. Like that, you had to you can fill up this table and you can determine all the moisture content, void ratio, degree of saturation, and you know from this chart different value of the dye density, and you know the different moisture content. So, you can make a correlation between the dye density and moisture content for the modified Proctor test. So, what you can, that you can draw the curve in between moisture content in the x axis and dye density in the y axis, and you can see the curve for defined value of moisture content. You are having the defined dye density and it reaches to the peak value, and then it decreases the density with increasing the water content. So, you can have a nature of curve like this, and from this curve you can determine that what will be the maximum dye density here, maximum dye density. You can calculate that what will be the optimum moisture content. It is optimum moisture content here, and this is the maximum dye density you can determine from here. So, here optimum moisture content is about 13.8 percentage and maximum dye density is about 1.54. You can draw also that define void ratio value on this side. So, this is the relationship between the dye density and moisture content, and from this curve you can determine that what is the maximum dye density and optimum moisture content for the modified Proctor test. Now, we determine the zero air void line for the modified Proctor test. So, how to calculate the zero air void line? So, determination of zero air void line, zero air void line. So, zero air void line can be expressed as gamma d is equal to G into gamma W divided by 1 plus W into G, where G is the specific gravity. So, specific gravity value you know 2.5, gamma W value you know that is 1, and this 1 plus again that this is W and this is D. So, W is 0.1 into G value is 2.5. So, this gives the dye density value about 2 gram per cc. So, you know that gamma D value, also you know that what is moisture content. So, from this you can draw the zero air void line. Here it is shown, this is the modified Proctor test diagram, dye density versus moisture content, this is the curve, and this is the curve for the zero air void line. This is 100% saturation. So, we calculate that gamma D is about 2 gram per cc, and you know at a particular moisture content, that is moisture content when it is the 10, that means you know that this is moisture content is 10% and then you calculate gamma D is equal to about 2 gram. So, for this 10% moisture content, so and the dye density is 2. So, you can have a point like this. So, similarly, for the different moisture content, then you can calculate the dye density using this equation. So, you can have a several point like this and then you can draw the, this is the zero air void line. This is called the zero air void line, zero air void line. So, this is for the modified Proctor test and how you have to calculate the zero air void line. So, similarly, you can calculate for the different air void line. Here it is shown that this is zero air void line when S is equal to 100%, when this S is equal to 80%, when S is equal to 70%, and when that S is equal to 60%. For different degree of saturation, also you can draw this line. So, for the different percentage, I am showing you one calculation how you can draw the gamma D for a particular degree of saturation. Let us say that gamma of D is equal to G into gamma W, this divided by 1 plus W into G, this divided by S. Now, if you consider that I need the degree of saturation S is equal to 60%, that means this is 0.6, that means S is 0.6. We determine what is gamma D. So, gamma D will be equal to, you know, G value is 2.5, gamma W value is equal to 1, this divided by 1 plus, and then for a particular water content W, let us say this 1%, 1%. So, this will be the 0.1 into this is 2.5 G value, this divided by S, S is 60%, that means 0.6. So, you can calculate that gamma D will be equal to 1.764, this is gram per cc. So, you can calculate gamma D 1.674 for a particular that water content. Okay? Water content, let us say this is 10% water content, 10% water content. Okay? So, here is the figure, you can see that gamma D value which you have calculated about 1.764, this is 1.764 gamma D. So, corresponding gamma D and for a particular moisture content of 10%, so you can get a point and in which that S value is equal to 6 degree. So, for the degree of saturation 60 degree, you can draw a line. So, you can similarly you can draw the line for the 80 degree, 70 degree. So, for this modified Proctor test, if you can draw the maximum dye density and the corresponding the optimum moisture content. Also, you can draw the zero air void line or different degree of saturation, and this modified Proctor test is also very important for any infrastructure project. Thank you.